Good morning, everyone. Can you see my screen, everyone? Online guys?
Yes, we can see you.
Yeah, fine. So we have completed 4 demos, right? So DevOps introduction, cloud introduction, and also we discussed about technical questions, general questions, right? And in the last session, we discussed about SDLC, software development lifecycle, right? Yeah. So today and tomorrow we are going to work on this servers and networks, right? So before going to cloud introduction, before going to start AWS, right? We need to understand servers, networks, basics, right? So if you understand this basics, you can easily understand cloud terminology, right? In cloud terminology, so say what is network, what is IP address, routers, subnets, gateways, clusters. Those are all will be covered in the servers, networks, basics, right? So this terminology is very, very important. Fine. So before going to start AWS, so day after tomorrow, we are going to start AWS. Before going to that, so we need to understand this servers, networks, basics. Fine. Yeah. Anyone new guys joined today? Can you please respond in the chat so that we'll provide you all the recordings, right? You can go through the recordings and you can continue from today onwards. Okay. So 4 demo sessions completed. So today onwards, regular sessions. Okay. Servers, networks, today servers, tomorrow networks, right? Yeah. So day after tomorrow, we will start AWS, right? So AWS takes nearly 35 days to 40 days, right? So we will go very deep dive. Every service, practical oriented sessions, right? Practically, we can configure the resources, right? Yeah. Anyone new guys joined today? First session? Can you respond in the chat? Fine. Yeah, let's get started. Yeah. So today's agenda here is what is server, types of servers, server client model, and best practices. Server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet, gateway, router, and firewall, and failover, load balancers. Okay. So today up to here, up to operating systems, we can will discuss here up to here. So this will take nearly 1 hour a day. Okay. So what is server, types of servers, server client model, best practices, server architecture, what is operating system, types of operating systems. So these models we can cover today. So tomorrow we'll start from networks. Okay. Yeah. So basically what is server? So always we work on servers, right? Always we connect servers. Developers always connect the servers. They develop the applications, right? So testers also always connect the servers. They test the applications. So as a DevOps engineer, as a DevSecOps engineer, right? We can deploy the applications on servers, right? What is server basically? What is server? Server is a computer, Andy. Simply you can say it is a computer, right? That serves information to other computers called clients, can connect to a server through either a local area network or wide area network such as the internet, right? So we always connect the servers in real-time projects. We always work on servers. Fine. Server is a computer that serves information to other computers called clients. What is client? What is client? Right? So desktops, laptops, right? So can connect to a server through either a local area network, LAN, or wide area network, WAN, such as the internet, right? Yeah. Now let's move on. So here we have types of servers, 3 different types of servers available, right? So here, blade server, this is the blade server, and second one is rack server and also tower server. So this is a old server, very traditional one, oldest one, right? So rack also traditional one. So this is the latest one. Blade server, rack server, tower server, right? Let's go with one by one. Let's move on. A blade server, yeah, blade servers. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. Look at here, everyone. So this is the container. In this container, we insert blade servers, right? So each container capacity, it can be 10 or 20 or 30, like that, right? So here we have how many servers? 10 servers. 10 plus 10, right? So 20. So rack size here, blade size 20. So 40 also there, 30 also there, right? Yeah. So these servers are physically thin and typically only have CPU, memory, integrated network controllers, right? Only CPU, memory, integrated network controllers. What about storage? What about storage? So for this blade servers, we always use the external storages like EMC storage, NetApp storage, Hitachi storage. So external storages we can use for this blade servers. And sometimes storage drives built in. So sometimes we attach storage drives to the thin servers, blade servers, right? Yeah, blade servers often seen in large data centers like a Google data center, Microsoft data center, UHG, Verizon, right? AT&T. So this enterprise level data centers we use the blade servers. Okay, fine. Second one here is rack server. Rack server is the look at here. A rack server is a server mounted inside of a rack. So this is a rack, right? Here we can insert the servers inside of the rack, right? So rack servers are typically general purpose servers, right? That supports a broad range of applications and computing. So this is the traditional one, and every data center they're using rack servers, right? Next one, towered server. What is towered server? Towered server is the computer. It is a computer that is built-in upright cabinet that stands alone and that is designed to function as a server, right? So this is standalone server. This is very oldest server, bit costlier. So currently we are not using, right? Yeah. So most of the data centers they are using rack servers and also blade servers. Fine. So these are the physical devices, right? So in our previous, in our Capgemini, in our previous organization, so when I work with the Capgemini, so I used to handle the data center, right? So most of the servers, yeah, these servers, rack servers, nearly nearly 109 racks we used to use. 109 racks nearly. Okay. So this, blade servers also available, but very few. Okay, fine. So currently, most of the organizations they're trying to use cloud servers, right? Because cloud servers are, yeah. What are the advantages of cloud, Andy? Anyone? So cloud servers. When we use cloud servers, what will happen? Costing will be reduced, time will be reduced, right? So client always look for the cost saving, time saving, right? So when we, yeah, if you want to use the physical servers, so if any client required any servers, yeah, if you want to configure 10 servers, for example, physical servers, that takes some time, right? So on the fly, so on demand servers we cannot provide in the physical. Physical is not on demand, right? So cloud servers are on demand. So whenever the client required, whenever the project team required any resources, so on the fly by single click, we can create a number of resources, which is on demand, right? But whereas physical, it takes some time to provide the resources. Fine. So these are the three types of servers available. Now look at here. So client server model. This is the client server model. So here, this is the server. These are the clients, right? When you send request to the server, it will give response immediately, right? So all the normally in the development environment, every developer, so they connect servers, they develop the applications on servers, right? Yeah, sometimes they connect and they copy the data into other servers, they modify the data, they change the applications, right? They change the updates, front end, back end, databases. So developers always work on the application development, right? So they connect servers. Fine. Yeah, this is another model. So we can connect our servers through internet. So we can use either a desktop or laptop. Even we can use the tabs also to connect our servers, right? Now look at here, everyone. Server architecture, right? So this is the foundation layout or model of a server. So based on which a server is created and are deployed, right? So it defines how server is designed. So look at here. So here servers we have, databases we have, right? Yeah, different components available here, right? Now let's try to understand few examples of server architecture, right? Yeah, server architecture, initial phase of implementation, which we can say first phase of implementation. First phase of implementation, right? Yeah. So here, in initial phase of implementation or first phase of implementation, how the project teams used to design their server architecture, right? So in 1990s and early 2000, in 1990s and early 2000, how the project teams they used to design the servers, how they used to configure the applications. Let's try to understand here. Okay. So before going to discuss about cloud environments, cloud infrastructure, so we need to understand this, right? Yeah. So for example, we have four applications like Java, Python, and .NET, right? And also Tomcat. So we have four applications, right? In 1990s and early 2000, project teams used to take, for each application, they used to take one server. For every application, they used to configure separate servers, right? Java. So they used to configure one server for Java, right? Like that. So in 1990s and early 2000, highest capacity of the storage is 1 GB and highest capacity of the storage 1 GB, right? So these are all 1 GB servers. These are all 1 GB servers. These are all 1 GB servers, right? So for example, these are the four servers, four applications we have, right? So project teams, they used to configure four servers here on four servers. Yeah. So here, for example, they configured Java. So Java occupied, for example, 300 MB, right? So remaining 700 MB will be wasted, right? So remaining space will be wasted, right? Here 700 MB, right? So this space will be wasted. So next one, Python. Python occupied, so here 350 MB, for example. Remaining space will be wasted, right? So here 650 will be wasted. Next one, .NET. So .NET application occupied 400 MB, for example. So remaining space will be wasted here. 600 MB will be wasted. So next one, Tomcat. Tomcat is the web server. Tomcat occupied 500 MB, for example. So remaining space 100 MB will be wasted, right? So like this, every project team, they used to configure one server, a separate server for each application, right? Right. So in 1990s and early 2000, hardware costing, it's a too much costing, right? Someone unmuted. Any questions and anyone? Right. Fine. Yeah, in 1990s and early 2000, highest this server costing, server's physical hardware costing, it's a too much costing. So clients, they used to spend more budget for the hardware, right? So even laptop desktops also too much costing, right? So they used to spend more budget for the hardware in 1990s and early 2000, right? Yeah. So here server utilization is very less, but costing is too much costing. So that is why. So this is the failed model, Andy. This is the failed model. This model is failed completely because not budget friendly. This is not budget friendly, right? Client always look for the budget, right? Cost saving, right? So this is not budget friendly. That is why, yeah. So clients slowly, what happened? Slowly, what happened? Yeah. After 2000, so what happened here? In second phase of implementation, second phase of implementation, yeah. So clients used to take high-end capacity of the server. They used to take high-end capacity of the server. So they used to deploy all the applications on this server, right? For example, here they deployed all applications, four applications, Java and also Python and also .NET and also Tomcat. So they used to take high-end capacity of the server. They used to configure all the applications on the same server, right? So here, Java user may access Java application. Python user may access Python application. So .NET user may access a .NET application. So Tomcat user may access Tomcat application, right? So they can access their respective applications. But here, Java user may access Python application also. There may be chances to access. Python user may access .NET application also. There may be chances. Here, .NET user may access Tomcat application also. Because for the four people, they are accessing same server, right? There may be chances to access other applications also. So firewalls will be there. Security will be there, right? Normally, so when we configure servers, we configure the security. But still, there is a chance to access other applications also. Other applications. Fine. Yeah. So here, if they access other application, that is security concerns, security violence, security violence, right? That is one drawback. Also, in case the service crash, ఏం జరగవచ్చండి? So the service crash, server crash అయింది అనుకోండి. What will happen? All the applications will be gone. All the applications will be gone. So this is one more drawback. This is one more drawback, right? So that is why, yeah. So here in second phase of implementation also it was also, so this is also failed, right? So failed concept, second phase of implementation also failed, right? Yeah. Slowly, what happened? Move on, let's move on. In next phase of implementation, which is third phase of implementation, third phase of implementation, what happened here? Yeah, the project teams used to configure virtual environments. Virtual environments. Virtual servers came into the market, right? What is virtual server, anyone? Anyone having idea? Virtual server అంటే ఏంటండి? Anyone? Virtual server. which is not physical and which is imaginary server. Virtual server is not a physical server, which is a imaginary server. Imaginary, right? So am I audible and everyone? Can you confirm please one more time?
Yes.
Yeah, fine. Yeah. In third phase of implementation, project teams, they started using virtual environments, virtual servers, right? Yeah. So here, virtual server is a, yeah, virtual servers. Virtual servers are, yeah, not physical. So these are all, we can say, imaginary servers. Imaginary, right? Yeah. So functionality wise, virtual and physical both are same, right? Yeah. What the importance of virtual servers? Let's try to understand. What is virtual server, first of all? Okay. So the project teams used to take one high-end capacity of the server, capacity server. For example, this is the physical server, high-end capacity server. So this we can say base operating system, base OS, right? So this server capacity, RAM 48 GB, CPU 32 core, and storage here 10 TB, like this. So high-end capacity of server. So we can take high-end capacity of the server. So on top of this, we deploy software, which is, we can say, yeah, this software is virtual software, which is, we can say, either VMware, or hypervisor, Hyper-V, or Citrix. So these softwares, these three softwares, virtual softwares, right? So when you deploy virtual software, what will happen? This will allow you to create virtual servers only. Okay, this software allows you to create virtual servers. So here, these are all virtual servers as per the physical server capacity. So we need to create virtual servers and we can use the virtual servers. So these are all the virtual servers, 5 into 5. So 25 virtual servers. So here we can deploy different operating environments. So different applications we can deploy, right? So here we can deploy RHCL, Red Hat Enterprise Linux. Here we can deploy Windows 2025 Data Center Edition, latest one. Yeah, here we can deploy Ubuntu Linux version. Here we can deploy SUSE Linux. Here we can deploy, yeah, CentOS, right? Different operating environments as per the client requirement. We can deploy and we can use, right? So fine, still we are using virtual servers. Still we are using virtual servers in real-time projects. But here also we have some drawbacks. In the virtual environment also, we have drawbacks. What are the drawbacks? Okay. So if you want to deploy operating system, we use ISO image. ISO image. What is ISO image? So ISO full form is International Standardization Organization, right? So this image is a, yeah, image is a master copy. For example, in your laptop, if you want to deploy operating system, how can we deploy? In our laptop. Yeah, if you want to deploy, for example, Windows, ఎలా deploy చేస్తామండి? So first we need to copy the image into pen drive. We need to prepare the image. That image, that pen drive, we can configure as a bootable drive. We can connect the pen drive and we can boot the laptop using pen drive. So after that, we can install the operating system, right? Yeah, if you want to deploy operating system on your laptop, we require image. Same way, AWS also providing, Azure also providing images in AWS. Same way here also, virtual environments required ISO image, right? So by using this image, we can deploy the operating system, operating environment, right? So this ISO image size would be, this ISO image size would be 6 GB to 18 GB. So 6 GB to 18 GB. So here we have 25 servers, 5 into 5. So on an average, each server can have 10 GB, for example. 10 into 25 equal to, so 250 GB we need to spend for only operating system, right? So 250 GB we can spend for only operating system. So on top of that, we need to install applications, plugins, patches, right? It will take more space. It will utilize more space. That is one of the drawback. Okay, because we need to spend more storage here. That is one of the drawback. Also, when you restart or restart, reboot, both are same. And when you restart your server, so that will take nearly 4 to 8 minutes. And 4 to 8 minutes. So client will not accept this much of time. Client, they will not approve for the downtime. Restart time is the downtime, right? So for example, Flipkart application is running on the server. If you down the server, right, for 4 to 8 minutes, what will happen? And ఏం జరగచ్చు? Client business will be impacted, right? So client business will be impacted. That is why, so client, they will not accept for the downtime. No downtime currently. We are using advanced environments. No downtime, right? So when you restart your server, it takes 4 to 8 minutes, right? And also deployment time and a downtime is high. Deployment time, downtime. So what is deployment and anyone? What is deployment? Anyone having idea? Real time, guys. Deploy.
Code deployment or
Code deployments, right? Application deployments or patches deployment, plugin deployments, right? It's a simply you can say installation. Okay. So deployment time and downtime. Downtime is maintenance time, right? Yeah. So deployment time and downtime is very high end here in the virtual environments. Fine. So moreover, license cost is high. Operating system license, application license, right? So client, they need to spend more budget for the licensing also. So these are all drawbacks. And still we are using 30% of the project team, still they're using virtual environments, right? Yeah. So now let's move on. These are all the drawbacks here. That is why currently every project team, they are migrating to Docker environment and Docker architecture, Docker and Kubernetes architecture. So these are all drawbacks in virtual environments. That is why, to reduce the costing, to reduce the downtime, to reduce the deployment time, to reduce the licensing cost, right? So clients, they are migrating their applications to Docker containers, right? Which is a fourth phase of implementation. Yeah, so fourth phase of implementation. In the fourth phase of implementation, so we are using Docker containers only. Docker containers. So these are all very advanced concepts and Docker is very advanced one. Okay. So currently, every project team, they're migrating their applications to Docker containers. So what is the importance of Docker containers? What is important? What is Docker? What is the importance of Docker containers? Let's try to understand here. Okay. So same as virtual environment, we can take one not physical, cloud server. We can take one cloud server, which is AWS EC2 instance. AWS EC2 instance. So server we can call it as EC2 instance అండి. సర్వర్ని మనం EC2 అంటాం AWSలో EC2 ఇన్స్టెన్స్. అదే Azureలో అయితే సర్వర్ని VM అంటాం, రైట్? So whereas GCP we can call it as VM instance. So terminology would be little different. So all the cloud platforms are same functionality. AWS, Azure, GCP, Oracle Cloud, Alibaba Cloud, DigitalOcean, Fastly, Heroku, nearly 30 more clouds are there. So every cloud platform is having same resources, but terminology would be a little different, right? So we can create one AWS EC2 instance. On top of this, we deploy something like Docker image, Docker image, right? Once we deploy the Docker image, this will allow you to create Docker containers. This will allow you to create Docker containers. Fine. So these are all containers. These are all containers. In these containers, we can deploy the operating environment, right? Whatever the operating environment required. So here I can deploy RHCL. Here I can deploy Ubuntu. Here I can deploy SUSE Linux. So I can deploy Windows latest version, right? Yeah. In Docker environment, so when you want to deploy any applications, we don't use ISO image. We use the Docker image and Docker image we use, right? So Docker image. So when we want to deploy any operating environments, we use the Docker image. So this Docker image size would be 200 MB only, Andy. 200 MB only. Docker image size would be 200 MB. So here 6 GB to 18 GB, right? Here 200 MB only. It is lightweight, Andy. This is very lightweight, standalone executable program. Docker images are lightweight, right? So this is not lightweight. It is a full-blown operating system, but this is lightweight, right? Yeah, and also when you want to restart containers, it takes 15 seconds only. So within 15 seconds, the container will be restarted. So if the developers are working on the container, they will not understand, okay, this is restarted or not. Okay, very quickly, very faster, right? So now next one, deployment time, deployment time and a downtime is less, and very less. So when you want to deploy any applications, so we can quickly deploy on the Docker environment, Docker containers. So when you want to down quickly, we can restart, right? So moreover, no licensing, Andy. No license, right? Because vendor will take care. Vendors will take care. AWS, Azure, GCP, they will take care. So we don't need to pay the extra licensing here. So when we are using server, right? That server license only we have to pay, right? Yeah. So server license means not license actually. That is hours. How many hours you are using? For that hours we have to pay the bills, right? So here better we can say here no license anakandi. So license cost is very less. So we can say cost effective, or else we can say less licensing cost, right? So these are all advantages of Docker containers. And currently every project team, they are migrating their applications to Docker containers to reduce the costing, to reduce the time. So client always look for the cost saving, time saving. Every client, right? So that is why they are migrating their applications from physical servers or virtual servers to cloud environments and Docker infrastructure. They're migrating. They're migrating to. So once you deploy the applications on Docker environment, okay, yeah, so no downtime, nothing, no extra costing. So that is why every client, they're migrating their applications to Docker containers. Clear and everyone? Any questions up to here, anyone? Anyone having any questions up to here? So the difference you understand, right, everyone? Virtual environment, virtual softwares, virtual servers, and Docker containers. So containers are not servers, Andy. Containers are not servers. Container in general, container is the box. Container is the box. We can move anywhere, we can use anywhere. It's a lightweight, standalone executable program. So while working on Docker, so I'll show you practically. So practically, we can create and configure the containers. We can deploy the applications. We can run the applications, right? Practically, we can work on this while working on Docker. Fine. Yeah. So Docker Docker or Docker released in interview questions అండి 2013. Docker released in 2013. So after 1 year, Kubernetes release అయిందండి. After 1 year, Kubernetes released. Kubernetes implemented in 2014. Yesterday we discussed this, right? Yeah. So Docker implemented in 2013, Kubernetes implemented in 2014. So why the Kubernetes released immediately? Because Docker also having some drawbacks, clustering issues, and Docker cluster issues, right? So Kubernetes is having Kubernetes is not having any cluster issues. Okay. Yeah. So Docker and Kubernetes both are very core tools, very advanced tools. If you are good in Docker and Kubernetes, you can easily crack your interview along with AWS or Azure or GCP. Docker Kubernetes, we need to be very strong, right? So that you can easily crack your interview, easily cope up in the projects. So along with this CI/CD కూడా knowledge ఉండాలి. కొంచెం CI/CD కూడా knowledge ఉండాలి, right? Fine. So here Docker supports 95,000 containers. Yesterday we discussed. It supports 95,000 containers అండి. 95,000 containers. Kubernetes supports 3 lakh containers. Right? So creating cluster is very easier in Kubernetes. Creating cluster is difficult in Docker, right? So we have differences, nearly 8 to 9 differences while working on Docker and Kubernetes. So we will discuss about them. Okay, fine. So these are all advantages of Docker containers, okay, and Kubernetes. Now, yeah. So here, look at here. So this is the architecture. So while working on AWS VPC, we will go very deep dive about the architecture. Okay. So this is server architecture. So in server architecture, we use servers, storage, network, load balancers, right? Yeah. So different components. Fine. Next, move on. Look at here, everyone. Yeah. So here, what is operating system? What is operating system? Look at here, everyone. Operating system అంటే ఏంటండి? Anyone?
It is
Can
a
you see?
software.
Yeah. Go ahead and yes.
It
Operating.
is a it is a software where I mean uh,
Yeah.
sorry, you can continue.
Fine and fine. No problem. So for example, we are using Windows, Andy. In our laptop, we are using Windows, right? Yeah. So computer hardware always understand binary language, Andy. computer hardware, any computer, it can be server, desktop, laptop, anything. Computer hardware always understand binary language. Binary language is zeros and ones. 000, 001, 100, 111, like that, right? So computer hardware always understand binary language, but a human will not understand the binary language, right? That is why we required one translator, which is operating system. So operating system, it translate binary language to human readable language and human readable language to binary language, right? It is an interface, and the operating system is an interface between the user and the computer hardware. Look at here, everyone. This is a definition which I collected. Look at here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. 000, 001, 100, 111, like that, right? In such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? It is a mediator. Operating system is a mediator between user and the computer hardware, right? Look at here. So hardware and end user between, So here we have operating system, right? So operating system translate from human language to hardware, from hardware to human readable language. Fine. Next one, types of operating systems. Types of operating systems. What are the types available? Look at here, everyone. Single user, single tasking operating system. In this type of operating system, only one user can log into the system. He can perform only one task at a time, which is single user, single tasking operating system. For example, MS-DOS, Microsoft Data Operating System, right? Which is a very old operating system. In this operating system, only one user can log into the system. He can perform only one task at a time, which is single user, single tasking operating system. Second one here is look at here. Second one, single user multitasking operating system. In this type of operating system, only one user can log into the system. He can perform multiple tasks. One user can log into the system. One user can log into the system. He can perform multiple tasks. For example, Windows, right? In Windows, while browsing internet, we can run background audios. While working on any activity, we can run audios, right? Single user multitasking operating system, right? Next one here is multi-user multitasking operating system, which is very popular one, very important one. So currently we are using in projects. So multi-user multitasking operating system, which is Linux, and right? Every data center they're using Linux servers. Every data center, because Linux is more secure. So multi-user multitasking means multiple users, they can log into the system, they can perform multiple tasks at a time. For example, developer develop the code on their local workspace, local systems. Once the development is completed, they push the code to remote repository, which is GitHub. Yesterday we discussed. Once the code is moved to GitHub, so by using Jenkins, we can pull the code, we can convert into artifact, we can deploy onto respective target servers, Tomcat server or JBoss server or WebLogic server, any web server we can deploy, right? While deploying the applications, developer login into the servers, testers login into the servers, DevOps engineers also login into the servers. They perform their tasks, which is a multi-user multitasking operating system. Multiple users, they can connect servers, they can work on multiple activities, right? So desktop side, we are using, desktop side and laptop side, we are using Windows, but server side, we always use the Linux. So most of the servers we are using in data centers, right? Linux servers only. So 95% of the servers we are using Linux, only 5% Windows servers. Clear, right, everyone? So these are the types of operating systems, right? So in these types, we have flavors, different flavors. Linux is having different flavors like Ubuntu, Fedora, Amazon Linux, right? RHCL, CentOS, different flavors are available. In Windows also, we have different flavors like Windows 2000, 2025, Data Center Edition, 2023, Data Center Edition. So like that, different versions available. Fine. Yeah. So tomorrow we'll start networks. Okay. So networking concepts here, these are all very important. And networking terminology is very, very important. So tomorrow, do not miss the session. Okay. So networking terminologies. So we can go through all the important components and configurations, right? So before going to AWS, first we need to understand these terminologies, right? So tomorrow you can attend the session. Okay. So the people who are not registered so far, you can register today itself. The link will be changed tomorrow, right? So today is the fifth session, right? So yeah, 5 sessions allowed, right? So make sure you can register today. You can contact our admin. So they will help you to give the information, everything. They explain the how to register and all, right? You can register and you can add into the WhatsApp group. WhatsApp group already created. Our batch number is 106 and okay. Already 7 members registered, 7 to 8 members registered already. Okay. You can register as soon as possible and you can add into WhatsApp group, right? And also Google Classroom and Google Drive. We have Google Drive configured. In that, I upload all the documentation. You can download the documents. So daily basis, once we start working on AWS, so daily basis, daily I upload one document, soft copy. You can download. Recordings also you can download, you can access from Google Drive and we upload into Google Drive recordings. You can access 1 year. Fine. Any questions and anyone? Anyone having any questions here? Fine. Yeah, so we can stop here. Yeah, so you can register today and you can add into WhatsApp group and also Google Classroom so that we'll share all the documentation recordings on Google Drive, Google Classroom. You can access. Fine. Yeah, if anyone having any questions, you can reach out to me. So my number already shared with you. My mobile number is 96422 11711. 96422 11711. Right? You can reach out to me. Yeah, we'll discuss if you have any questions. Fine. Yeah, we can stop here. So tomorrow link may be changed. You can register as soon as possible. Fine. Yeah. Thank you all, Andy. Thank you all.
Thank you.